Welcome to Daily Papers, the podcast where we break down the most interesting academic papers into something you can actually understand.
Today we're talking about a problem that anyone who has used an AI chatbot has probably run into, when the AI just makes stuff up.
Right, you ask it for a fact and it gives you an answer that sounds completely plausible, super confident, and is just flat out wrong. In the world of AI, this is called a hallucination.
And it can be funny when you ask for a recipe and it invents a new kind of vegetable, but it's a huge problem if you're using AI for things like medical research or financial analysis. A confident-sounding error there could be disastrous.
Exactly. So researchers are in a constant race to figure out how to stop these hallucinations. Today's paper, Zero Knowledge LLM Hallucination Detection and Mitigation Through Fine-Grained Cross-Model Consistency by researchers at Amazon Web Services, presents a really clever new strategy.
That is a mouthful of a title. Let's break it down. The most important part might be zero knowledge. This means their system doesn't need an external database or a big book of facts to check against. It can spot and fix errors without looking anything up on Wikipedia, for instance.
And how does it do that? Well, let's talk about how other systems tried to solve this first. One common method is to ask the same AI the same question, but phrased in a few different ways. If it gives consistent answers, you assume it's correct.
But the paper points out a big flaw in that logic. If an AI is really convinced of a wrong fact, it will just confidently give you that same wrong fact over and over again. It's like asking someone who's bad at math, what's 7 times 8? And then asking, if I have 7 groups of 8, how many do I have? They're just going to give you the same wrong answer both times. They're stuck in their own little bubble of wrongness. So this new system, called FinchZK, takes a different approach. Instead of asking one AI the same question multiple ways, it asks a whole panel of different AIs.
It's basically creating a wisdom of the crowd for AI models. The core idea is that while one model might have a weird misconception, it's much less likely that a whole diverse group of models like Llama, Claude, and others all share the exact same misconception.
So let's walk through how FinchZK actually works. It's a 3-stage process. The first stage is cross-model sample generation.
Sounds technical, but the idea is simple. FinchZK takes your original question and, like a good journalist, it creates a few variations of it. Then it sends these questions out to its panel of diverse AI models. It collects all of their answers, creating a big pool of different perspectives on the topic.
So now it has the original answer it wants to check, and this big collection of second opinions. That brings us to stage 2. Fine-grained hallucination detection.
This is where it gets really clever. Instead of just looking at the whole answer, FinchZK breaks the original response down sentence by sentence. This is the fine-grained part. It then appoints another AI to act as a judge.
The judge's job is to take each individual sentence and compare it against the pool of answers from the other AIs. If the sentence is supported by what the other model said, it gets a green checkmark. But if it directly contradicts what most of the other models said, it gets a big red flag.
This lets the system pinpoint exactly where the hallucination is. It's not just that the whole paragraph is wrong, it's that this one specific sentence about a date or a name or a place is the problem.
Okay, so we found the error, now what? Stage 3 is the multi-stage mitigation, or in simple terms, the fix.
And again, it's very precise. For each red-flagged sentence, FinchZK calls in an improver AI. This AI's job is to rewrite just that one sentence based on the correct information it gathered from the panel of other AIs. It's like a surgeon performing a precise correction, not a demolition crew tearing down the whole building.
So it patches up the bad sentences, leaving the good ones untouched. Then there's one final step. The system takes this corrected text and asks the improver AI to do one last read-through, polishing the whole response to make sure it's coherent, accurate, and flows well. And the results are pretty stunning. The paper shows that FinchZK significantly improves the factual accuracy of AI-generated text. For detecting hallucinations, it improved scores by anywhere from 6 to 39% compared to existing methods.
And for mitigating them, actually fixing the errors, It achieved a 7 to 8 absolute percentage point improvement in accuracy on a really tough dataset of graduate level questions. It even outperformed systems that do use external knowledge bases to fact check.
That's the really wild part. By just having AIs check each other's work, FinchCK was more effective than a system that had an open book test. It shows just how powerful this cross-model consistency approach can be.
Of course, it's not perfect. The paper notes a couple of limitations. First, it's computationally expensive. You have to run a bunch of different AI models at once, which takes more time and energy.
And second, there's the small but real risk that all the models on the panel could have the same blind spot or bias. If every AI you ask has been trained on the same flawed data, they might all confidently agree on the wrong answer, an AI echo chamber.
But even with those caveats, this is a huge step forward. It provides a practical, deployment-ready way to make the large language models we use every day more reliable and trustworthy.
It's a powerful reminder that sometimes the best way to find the truth isn't to rely on a single voice, no matter how confident it sounds, but to listen to a diverse chorus of them.
That's all the time we have for today. Thanks for tuning in to Daily Papers.